Welcome back. In this video, I wanted to show you how to get started with the programming assignment if you haven't yet. Now, it is due on Friday. That's just two and a half days from now. So um, hopefully you already have. But for those of you who have been having difficulty with that, let's go over a little bit. So here I have my directory. I called it PA4 work. This contains just the provided code right now. I'm going to write the outline of a main function, and I'm going to do this in C++. So first I need to modify my makefile, because I'm going to use shell.cc instead of shell.cpp, meaning it will use the CSX flags. Also, because I'm using C++, I need to use the C++ linker, so the C++ standard library is included. So I need to change that to CXX, and here I need to use CXX flags. So the precise command I need is given here. And with that, that's all the changes I need to make to my makefile. So let's edit shell.cc. So I know I'm going to need to include IOStream. I'm also going to need to include shell.h so that I have the declarations for all the functions in the parser library, and I have the definition for that command struct. Since I'm writing in C++ rather than C, I can refer to command as just command or command star instead of struct command or struct command star. I am going to need, of course, many more header files eventually, but for right now, this will do. I'm going to have a main function. I need my function to take command line arguments, or I need my program to take command line arguments, meaning main should be declared as taking an int argc. This is the number of command line arguments, including the program name itself. So if I call /shell, argc will be 1. If I call /shell space file name, argc will be 2. And argv will be a char star star. It is a pointer to an array of character pointers, and the size of the array is argc. So first, I should probably handle what happens if I call my shell with too many arguments. I should be able to have either 0 arguments, argc is 1, or 1 argument, argc is 2. But if argc is greater than 2, that means someone called /shell hello world or something like that, and I don't know how to handle that. I maybe could try running both script files in sequence, but for now, just report an error. All errors should be printed with be printed to standard error. In C++, that's C error. And if that happens, I can print an error message. I'll print usage. The 0th argument, remember, is the name of the program itself. I could just say shell here, but if I do this, it will be whatever my shell happens to be named, even if I rename the executable later. And then script file. The square brackets here are typically how you indicate something is optional, and the angle brackets mean that this thing is, that I wouldn't literally type script file, but I would plug in something here, the name of a script file. And I want to end the line. Again, I could end the line like this. And I need to exit with a non-zero status. So this is one of the few cases where I don't need to have both a context and a cause of the error. I can just print the usage message. Okay. So now I'm going to need to handle reading from either standard input or from a file. So how can I do that? If argc equals to, and I could make that an else if. So if I was provided a error, then I'll need to, or if I was provided a file name, I will need to open that file, report any errors, and so on. So, well, if I'm going to be reading from a file, I need an if stream in C++. Now, the problem is if I put my if stream here, its scope is only going to be inside this else, meaning I would have to write all the loop that reads from it and everything inside here. That doesn't necessarily work so well. I could do that, but then when I handle the case where argc equals 1, I'm reading from standard in, I would have to do that. I'd have to do that separately. So let me make a stream for the script. So I will call open on that, and if so, I could say if scriptf.bad, or I could say if not scriptf. We'll do if scriptf.bad. And I need to hope here that errno got set. C++ standard library doesn't necessarily guarantee that, but we'll see whether it works. Could not open input file. It's nice to include the file name. Then I can do my colon. Notice I didn't put a semicolon. I'm still continuing the sequence of insertion operators. And I call stir error, and then I can pass an indel. Now I do need to include some header files for that. Stir error is in string.h. Errno is in errno.h. I also need to include my fstream header. Another thing that I've been leaving out so far is I haven't been writing std : : I maybe don't want to do that, so I can using namespace std, and now I can refer to cerr, indel, ifstream, and all those things just by their bare names. Okay, so now I have opened the file. There might have been an error. If that happened, I printed the error message and exited. Okay, so now I'm going to need to read in a loop from the appropriate file descriptor, or from the appropriate file stream. That might be scriptf, it might be cin. There are a few different ways to handle this, but what I can do, ifstream, this class in the standard library, inherits from a class called iStream. And guess what else inherits from iStream? cin. It's not an ifstream, but it is an iStream. So I can't just assign to another variable. So I can't say iStream nf equals blah, blah, blah. But what I can do is make a reference. And now I have to assign the reference with the appropriate thing. This is one place where that question mark operator, the ternary operator we talked about when we were covering implementing branches in assembly language, comes in handy. The thing is, if I make a reference in C++, I have to initialize that reference on the same line where it's defined. I can't assign to the reference later, or rather, if I try, that's actually doing an assignment to the thing that it's a reference to. And if I just did this, it wouldn't be a reference to anything. I would have an error just from this line. But if I did point it to something and I tried assigning, that would be calling the assignment operator. So not making my reference point somewhere else, but trying to stuff an IF stream into an I stream, which wouldn't work. We would have what's called slicing in that case. In fact, it probably wouldn't even compile because there isn't an assignment operator in the iStream class. But I can use this question mark operator to say something like argc == 2. So remember, I write my condition, then the question mark, what I want this expression to evaluate if the question mark, if the condition is true, which would be my script f, otherwise cin. So this is one way to do it. Another way would be to write a function that does all of your read loop and so on. Have that function take an iStream by reference, and then we can pass the function either the scriptf or cin. That would work as well. So now I can start writing my loop. Actually, I'm going to, since I'm doing C++, I might as well use C++ strings. That way I don't have to worry about allocating the appropriate buffer size and so on. So I'll make a string variable for the line. And then I can say something like while getLine of the input file and the line is true, do stuff. So every time we go through this loop, we're going to call getLine to read one more line. Well, I am going to have to include a new header file. So this is the C++ header file for string. Notice it's different from string.h. String.h is a C header file. So while getLine returns true, so getLine reads a line from the file stream or from the input stream, stores it into the line variable, and it returns a reference to the same input stream. And the reason it does that is, and the reason we can use it like this, is an input stream, when it's treated as a Boolean, when it's converted to bool, as it is in the condition of a while loop or the condition of an if, will be true if the last thing we tried, the last read we did, was successful, false if it wasn't. False here could mean we reached end of file, in which case we want our loop to end, or it could mean there was an error, in which case we want the loop to end. We'll have to check for that later, but for now, inside the loop, we know that we did just read a line and it was successful. So now I'm going to need a command star. So I'll call this maybe cmd equals, and then I can call parse command. Parse command being defined in shell.h. Now remember, parse command is a C function, so it takes a C string. So we need to convert our C++ string into a C string, but that's easy. Line.cstr. And I also know I'm going to need to free command on the command. So this might be a good starting point. I do want to do one more thing. So if the input file is bad, remember if we got out of this loop, it could have been an end of file, which isn't bad. It isn't an error. Or it could have been it could have been something worse. And otherwise, I can exit with status 0. So this program is just going to read lines and do nothing with them. Let's do maybe one more thing, just for testing purposes. Let's print out the 0th argument. Well, I want to be careful here. That 0th argument could be null. So if command args0, remember args is an array of pointers to strings. So args0 is a pointer to an array of characters. So if that pointer is null, this condition will be false. If it's not null, the condition will be true. And if it was false, meaning the first argument was null, if you remember from the last video, that means we didn't have any command. Someone just pressed enter, for example. Then we'll want to do nothing. And now maybe I also want to, instead of just printing the argument, print command, the command name, and end the line. All right. So actually, one more thing I wanted to mention, which is, how do we check for, or how do we print the prompt? Because remember, we only want to print the prompt if we're reading from standard in, not if we're reading from a file. And we can't just say if inf equals cin equals operator isn't defined on iStreams or streams in general. So we're going to need to do something else. Well, let's make a bool from script, which will be false initially, but then if we decide we're reading from a script, we'll set that to true. That also lets us improve this condition a little bit. And now I can say something like, so getLine is going to read the line. I need to, before I do getLine, print the prompt. I could do that here. So, and in C++, the way I flush is by doing something like that. And I will need to include iomanip for flush. Now that happens before the first get line. I also want to make sure I do that before a subsequent get line. So I can put it before the loop and after. There is another way to do it. I could do it with two expressions in the condition of my while loop separated by a comma. The comma operator means do the thing on the left, then do the thing on the right, and evaluate to the return value of the thing on the right. That might be a little cleaner in some ways, but a little messier in others. So I'm not going to do that here. Okay. So let's see if I managed to write this without any errors. I think it's very unlikely that I did, but we'll see. C++ takes a little time. And holy crap, it compiled. Let's see if it works. So if I press enter, it should do nothing. That was the case where the argument is null. But if I do something like this, it will say what the command is. Notice in this case, I did just a redirection. and there was no command. Well, that's because the redirection is not considered a command itself. So if I do something like that, that's going to give me the same null as the command. I can try cd exit 1 and so on. Well, if I don't have the exit command, how do I terminate my shell? Control D sends a end of file on standard in. And I press Control D, and notice my program did not print that error message because the stream was not bad. It was at end of file. End of file or bad can both make it make the stream be false, so make us exit our loop. But we'll only print this message if it actually was bad, which could mean there was some kind of error reading. That won't happen very often. It can be, in fact, kind of hard to deliberately make it happen, but we do still want to handle that case. Okay, so now I have a framework for main, and now instead of doing this part where I just print out the name of the command, now this is where I'm going to do my comparison. So I could say something like if command arg0. Well, I want to say if it's equal to cd, but equals doesn't do what I want. That would be comparing the pointers themselves. And, well, this pointer came from parse command, and this pointer is somewhere in the data section of my executable, so those are going to be different pointers. I could use the strcomp function from C. So if strcomp of the arguments and ls equals 0, that means they're equal. Or not ls, sorry. cd. So that would be one way to do it. I could also say if this. Now this might look like pretty much the same thing, but here I'm converting my C string into a C++ string. So then when I do the equals, well, I can't directly compare a C++ string to a pointer, or at least not with anything built into the language, but the string class defines an operator equals that works on strings, on C++ strings and C strings. So I could do something like that. And if that happens, now, of course, I would need to implement cd. Else if, and then I can repeat that for my other commands. And now in my else, I have an external command. Well, how do I handle those? Well, again, I've already got the start of that in my lab 3. Let me just add a message. So I can at least see that it recognized those. And now for my external command, let me pull up my lab 3 solution. Let me take my call redirected. Now remember, the call redirected function that you wrote is going to have some changes, but it's a good starting point. The big change here, actually, one change that we'll want to make, remember that in our command struct, the arguments are writable characters, not const char. So I can even get rid of that const, and that also lets me get rid of this cast. I don't need the environment anymore, but we'll fix that in a moment. Also, the output file. Well, the output file is actually a little more is optional now, so I need to be able to handle both cases. So let me take this, and instead of making it take all of these things, let's make it just take a command. Now, really, I'm not going to be modifying the command, so I can make it const. Okay, so if fork returned an error, I already handled that. Now this open, this is output redirection. So if the commands, let's take a look at shell.h to make sure we get the right name, out underscore reader. So if out underscore reader is not null, I could explicitly say not equals null, but that's what using a pointer as a Boolean means. Then I can do all this dupe stuff. My out file will be command arrow out reader. I've already got error handling for that case. Now, I also need to do something similar for input redirection, but I'll leave that up to you. Exec VE, I don't want. I want exec VP. And I need to figure out what to give for my program and my arguments. So the program is going to be what we actually execute. The arguments will be the arguments we pass in, which includes argument 0, which usually is the same as the name of the program. So what I can do here is for the program, that would be args0. And for the arguments, that would be args. And again, I don't need to pass in the environment, and I shouldn't pass in the environment. If you wanted to have the option of giving a different environment, you could use exec VPE, but that's beyond the scope of this assignment. All right, so now my error messages here, well, they're coming from p error instead. So they're not going to look quite like my ones below. I might update that for something more C++. I, in the parent, wait for the child, and then I return something. Well, actually, here we don't really need to return anything. So remember, here we have to handle 3 different cases. Had a bit of a hiccup with the video. Remember that we have to handle in our shell 3 different cases. So those would be if the program exited normal, or if the program exited normally, then if the exit status was 0, we do nothing. If the exit status wasn't 0, then do something like this. And you need to handle W if signal. You can read more about that on the man page. But now I at least have something that will partially work. Now I do need to make make sure I get the appropriate header file. So I'm calling fork, open, wait, exec VP, that also comes from Unistandard, and exit. So I'm going to need all, and Pierre, so I'm going to need all of those headers. Paste those in. And I also need this constant that I made in my lab 3 for the standard out file descriptor. Line 25. I changed my call redirected to just return void. Notice there is an exit here. Normally your shell shouldn't exit if there's a problem, but these exits are in the child process. So it's okay. It's not exiting your shell. It's exiting the child process. If you didn't have these, like if I didn't have this one, for example, then if executing the process failed, the child would return back into main, and the child and the parent would both be going through the loop, reading from standard in or reading from the script file, which would be extremely confusing. I would type exit, and that would exit one of them. I would have to type exit again to exit the next one. Okay. So the cd command is unimplemented. The exit command is unimplemented. What's going on here? So my ls command looked like something was happening. Oh, of course, nothing is happening because I'm not calling that call redirected, and I'll pass my command. Now, actually, at this point, maybe it would make sense to rename this to call external command or something like that. I'll just leave it as it is from now. So again, cd doesn't work, exit doesn't work. ls works, ls-l works. Redirecting to a file works. Redirecting from a file doesn't work because I haven't implemented that, so it's still reading from standard in now. But I'm a good portion of the way through my shell now. I could run the test, and I do get some errors. So let's take a look. Test 0 received unexpected error output. So that means when running test 0, my shell was not supposed to print anything to standard error, but it did. And this file is the file that has my shell's actual output. So let's take a look. It's still printing the prompt. Well, of course. I only want to print the prompt. I even said this as I was typing it, but I didn't actually write the code, when I am reading from a script. So if not, or only when I'm reading from standard in. So if I'm not reading from a script, then I'll do that. Same thing here. And now I'm passing many more of the tests. So many of these are just checking what happens with external commands. Does my shell correctly handle more than one external command? Does it handle, so that is several lines in my input file? Does it handle blank commands where I have nothing at all? Does it handle commands with lots of white space in them? If you use the parser, it should have. This one I failed. Command signal is testing do I appropriately catch Control C, the interrupt signal? I haven't done that yet. I talked about that in the last video, so that's something you will have to implement in addition to what I've shown here. Redirecting output works. Redirecting input did not work. Well, I don't have input redirection implemented. The tests about the CD command, CD success, CD home, those failed. CD failure happened to look like it succeeded because, well, this is trying to CD into a directory that doesn't exist, which should print an error message. And in my shell, whenever I do CD, it prints an error message saying CD isn't implemented. Test for set env, set env if there was a failure, set env if I didn't provide any arguments. Does exit work? So I still have a ways to go with implementing all of my external functions, implementing some of the additional features like signal blocking and input redirection in my external commands. But hopefully at least this was able to get you started on the program if you haven't yet. So thanks a lot, and I'll be seeing you in office hours very soon.